Good day, 10Cs. Welcome back to our systems of equations. We started solving. We initially looked at what a system was. Then we looked at the fact that we could verify systems. And last lesson, we looked at we could solve systems by manually graphing. Well, graphing still. Before we get to the algebra stuff, we can still graph the system of equations to get solutions. We can also do it with our calculator. We were introduced to the calculator, how it worked with lines last unit to create a line on our calculator and identify the x and y intercepts. Well, now we're going to use our calculator the exact same way, whereas last lesson we found this intercept and then we moved to get the points for our line manually using our knowledge of slope-intercept equation. Well, we're going to get this same line, but we're going to do it on our calculator. And then we'll get the second line, get it on our calculator, and figure out how to identify that solution, which is the common point on each line, but using the calculator. So, here's our first question. X plus y equals 2, 2x minus y equals 7. We want to figure out what x and y can be. Now remember, in order to do this with the calculator, the first thing is we want to go into that y equals button because that takes us into the equations. We need to make sure that we have our equations in y equals mx plus b form. So make sure we have slope-intercept form for each of those so they can effectively be put in. But we're going to put it in twice. We're going to put in y1 and we're going to put in y2. This would be our y1, that would be our y2. So we have to put two of them in. This is then, after we graph these simply by hitting the graph button, we might have to change, remember, the window display because we need to see the point of intersection. So you might have to play around with your window display each time in order to see on that graph. Maybe your window looks like this and you see the two lines going up and you see this happening, but you don't see the point of intersection. You'll have to change your window display to make it bigger so that we can see that point of intersection. All of this was covered in the previous chapter. Here's where it gets different. Once we now see what we want, our point of intersection on our calculator display, we're going to do second trace, like we did for the x and y intercepts. But after second trace, we need to choose 5 intersect, because that's what we want. We want the intersection point of these two lines. So we choose intersect. You might have to put the cursor a little close to the point of intersection just to make sure you get good results. And you're just going to hit enter 3 times. Enter, enter, enter. That's all you're going to have to do. And then all of a sudden, the bottom, there's your solution. So, with all that in mind, let's see what we come up with. So to start with, both of these equations need to be put into slope-intercept form. I want my positive y to stay, so I'm going to move x over. So I would have y equals, x goes over to be a negative x plus 2. Second line, my y is negative, so I'm going to move my y over, and I'm going to move my 7 over. That way my y will be isolated now as a positive y. And with the 7 going over, I'll be left with 2x minus 7. So there's my 2 lines in slope-intercept form for this system of equations. So you pull out your calculator. I need to pull mine up on the screen. Go to y equals, the top left button. Make sure again that negative x plus 2, we're using the negative button, not the subtract button. Negative x plus 2, there's our line 1. I scroll down to get to my y2 line, which is now 2x minus 7, and I hit graph. There you go. We can see in this case that we have the point of intersection nicely. So what did we say we need to do? We want to go second trace, second function trace, but this time we want the point of intersection number 5. So we take that. Now, I've been told you don't have to, but I just feel better if I move my cursor a little closer to the point of intersection because that's what I'm like. And basically, if you look at the bottom, it says first curve. Yes, we want the first curve involved. Yes, we want the second curve involved. Yes, please guess the answer. And at the bottom of the screen, it tells us what our solution is. Our point of intersection is at 3, -1. So I can now go back and I can say my solution is 3, -1. 3, -1 is the solution. How do we know that's correct? Well, what can we always do? Well, we're saying that 3, -1 is our solution for the original system, x plus y equals 2 and 2x minus y equals 7. What does that mean? I should be able to plug in my x and my y and get my left side to equal my right side. Second equation in our system, plug my x in, plug my y in, 2 times 3, subtract y, which is -1, so I want to subtract -1, which gives us 6 subtract -1, change if that helps you. 7 equals 7, left side equals right side, so we know the 3, -1 is the correct solution. Calculator can do the work for you. Now, what you have to be careful with the calculator, yes, it's there to help you. And there's the one that we just did. But if this question said graphically solve, graphically means do it on the calculator. There's nothing wrong with that. If this question had said algebraically solve, that means the calculator, if you just put answer for this and said, oh, it's 3, -1, algebraically, which we're going to get to, means you have to show work. If you don't show any work and it says algebraically, it's wrong. You haven't shown me you know what you're supposed to do. However, understand now that we know how to do it on the calculator graphically, if you showed all your work algebraically and did a nice job and came up with an answer, there's nothing wrong with pulling out your calculator and graphically solving to see if your answer is correct. The calculator is a great way for you to check if you've algebraically done it correctly. So take advantage of that. So here we go, number 2. Y equals 2x minus 5. I like the form of that. That's good. Get the y by itself. I like that y. It's already a positive y, so negative x is going to go over. So we have y. X goes over to be the -x plus 8. There's equation 1. There's equation 2. Y equals mx plus b form. I'm going to put it in. Maybe adjust my window settings if necessary. Second trace, number 5. Enter, enter, enter. And there's my solution at the bottom. So let's put up the calculator. I go into y equals. We're already finished with that question, so I want to go to both of them and clear them. And now I put in exactly what we just had. First equation was 2x minus 5. Second equation, we worked it out to be a -x plus 8. And now we graph it. Again, nice. Our window gives us exactly what we need. So what do? At this point, second trace, scroll down to number 5, or you can just hit number 5, intersection. Again, I'm going to go up close to the point of intersection because I'm just that guy. First curve, it asks. Yes, we want to include the first curve. So enter. Do we want the second curve? Yes, we do. Do we want to guess the answer? Yes, please do that for us. Now, in this case, 4.3 repeating and 3.6 repeating. Depends upon what the question says. If it says round your answer to the tenths place, hundredths place, you can. But I'm hoping at this point, decimal 3 repeating, we can be pretty precise. That's 4 holes, and 3 repeating is 1/3. 6 repeating would be 3 holes and 2/3. So if it asked and told you could round, you could round it, but those are a couple fraction decimal forms you should be able to come up with. So now we can go back, and what was our solution here? Our solution was 4 1/3 and 3 2/3. There's the solution. Calculator does the work for you. Question 3, pause the video, give it a try. See what you come up with. See if you can get the right answer. Maybe even verify. Go. So for me, here we go. I want to get y by itself, so I have to move the 2x over. When I do that, y will be isolated. My 2x becomes a negative 2x with the positive 3 on that side. A little bit more work here. I like my 2y. I'm moving the 3x over. So I would have 2y equals 3x becomes a negative 3x on the other side plus 11. Divide by 2. And y equals negative 3/2 x plus 11/2. So that's now the 2 equations that need to be substituted in to solve for the solution. So back to the calculator, y equals, I want to clear the ones we already had. First equation to plug in is the negative 2x plus 3. And now our second equation, fractions. Remember to put in the fraction negative 3/2, bracket, negative 3 divided by 2. There's your fraction negative 3/2 with the x, plus we want 11/2, bracket, 11 divided by 2, bracket. Brackets around your fractions to keep them as brackets, or to keep them as fractions. Sorry. At that point, there's my 2 equations. I hit graph. Now we have a little bit of trouble because we can see our point of intersection is going to happen up here. So I want to change my window setting. I think I'm okay every direction except up. What is that? That's the y-axis going up. So we need to change the y max value in our window. We want it to be higher. So we can hit window, y max, scroll down to y max. Instead of 10, I'm going to go to 20. Now I'll graph it. There's our point of intersection. That's what we needed. Second trace, down to number 5 intersect, enter, scroll so you're close to the point of intersection just because some people say you don't have to, I like to, enter, 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 and our solution is negative 5, 13. Right there, there's your solution. Go back to our page, and our solution is negative 5, 13. So graphing on the calculator, nice, fairly straightforward. I'm not worried about that. Let's go to the next page, word problems. So we can now start to look at word problems because with word problems, we can solve them graphically now. We looked at setting them up in lesson 1. Now we can work with it. So Allie wanted to try bungee jumping. She phoned 2 companies and found out the following. You could pay $40 for training, and then they're going to charge you $50 for every jump. Or they're going to charge more for training at company B, but they charge a little less per jump. So that's what the system is telling us. We need an equation to start that talks about the cost for each company based on the number of jumps. So that's our X and Y. So what's company A going to be? Company A, what's the cost? The cost is $40 for training up front once. Plus, we're going to pay $50 for every jump. So what we're really looking at here, y equals 40 plus 50x. Even though we're using different variables, remember, independent variables are x. What could change in this situation? How many jumps they take. That's independent, but cost is dependent on that. So our y and our x. Company B, same idea. Cost is $80 plus $45 times however many jumps. And again, see, the cost is dependent, y, on the number of jumps, which can change, which is our x. So understand which is y, which is x. So now it says to graph and find the intersecting points. So in this case, sorry, I didn't want to hit that quite yet. I want to go back and I want to graph those two equations. So clear. We want to, sorry, not graph, we want y equals. Clear our two equations. And now we can put those in. Our first equation was cost equals 40 plus 50n or 50x. Second company was $80 to start plus 45 times n or x, the independent variable. Graph it. Well, we can see here that our graph is off the screen. So where do we have to go? Well, we are going to have to change these. Let me just go back, see if I punch those in right. 40 plus 50x, 80 plus 45x. Graph it. What do we need to change? Our window has to go up. So we are going to window y max. This has to go way up. Let's go to that didn't work. Sorry, window y max up to 100 is where I want to go. So we still don't have the point of intersection. I think I messed up somewhere here. No, 40 plus 50x and 80 plus 45x. So our graph, we still need to go way up. So we can see that we still have to go way up on this. So back to window. I'm going to jump up big just to see if I can get my point of intersection. I'm going to go my y max to 1,000. See what happens. Well, that's better. But I still now see that I have to go to the right. So my x max, let's go 25 and graph that. There we go. Now we have our point of intersection. Here it is. Sometimes you got to play around with these. Sometimes you put big numbers in and then you can manipulate by going down. So there's our point of intersection. So let's figure out what our solution is. Second trace, intersect. We're right by the point of intersection. Enter, enter, enter. We get 8,440. So 8,440. If I sketch this just to get a visual of it, our first point of intersection, remember our equation here, cost is 40 plus 50n, and our second equation, cost was 80 plus 45n. Well, our point of intersection for company A, intersection was at 40 and the line went up. And then we had for B, intersect was 80 and then the line went up. And they intersected at point of intersection was 8,440. So we need to make sure we understand what the 8,440 means. What does X represent? What was our X value? Number of jumps. And what was our y dependent? That was cost. So understand what the two values mean. Independent says that this is the point where they're the same. When they've done 8 jumps with either company, the cost is the same at $440. So whichever company you go with, we see that they're exactly the same at 8 jumps, and it's a cost of $440. That's what the graph is telling us. So what's the minimum number of jumps for company B to be cheaper? Well, note that B is blue. So we see the cost is higher and it's even at 8 jumps. So when does it become a lower cost? After 8. We can see that on the graph. So company B is cheaper when 9 or more jumps are taken. Because before this point, which is 8 jumps, we see that company B is a higher cost. But at 8 jumps, it becomes the same, and then our cost is below the cost of company A. So 9 or more jumps, B is cheaper. If Ali jumps 20 times, what is the cost for each company? Well, this is where we can do some algebra. Company A was cost is $40 plus $50 for every jump, 20 jumps. B, the cost is $80 plus $45 for every jump, and we're saying 20 jumps. So when we calculate those, the cost of A for 20 jumps is $1,040. Company B, the cost of 20 jumps is $980. So what is the cost of each company? There's the cost for 20 jumps, because we can plug that into the equations that we have. Which is cheaper? Well, we can see, and we know that B is going to be cheaper because our graph told us that, and there you go. So using the calculator to graph as a support. Assignment booklet, page 10 and 11, and textbook questions. These are tricky because you have to set up equations, and they're a little ugly, which is why we would use a calculator. But you're going to have to mess around and play around with the window to get solutions to these. Some of them you're going to have fairly large window settings. Play around with it, see how you make out. But practice it and have fun.